Hello, everyone. Great to see you here, and thank you for coming, and thank to organizers for inviting me. And actually, Valentin has a great talk before mine, and he introduced many things, and even some diagrams that I will show you, he already discussed and presented. So I have more time to focus on other things which we were not presented. And also, in my presentation, I will talk about how to implement dialogue systems in production and how to solve real problems, but not only doing research, cutting-edge research as was demonstrated by Valentin. So, okay, let's start with the question why we are doing conversational AI right now. And certainly, the answer is the same, because we have a lot of messengers. You see the same graph, but how many companies do you have in your messenger? Almost zero. You see that a lot of people communicating via messengers, and it's a lot of time they spend in these applications. But almost no companies today able to communicate with their clients inside the messengers. And so the demand is huge, but technology maybe is not yet here, and we are working to make that possible. And people are not only chatting there, they are also spending money in the chats. Here you can see that now you know that China is one of the leaders in technology. And you can see here that even in 2 years ago, it was more than 16% of all the, more than even cash. You see here that more than cash was spent in WeChat. And I think that in the future, in all other countries will also go this way. And another problem where conversational interfaces and conversational AI can be applied is a smart home. So imagine if you have a home full of smart devices, like 100 devices or 200 devices or 300 devices. So what's like now the common way to control these devices? Yeah, you are using your mobile, some applications to turn off light, to turn on music, to like set up all the scenarios, what you want your smart home to do. But it's very complicated. If you have 1, 2, 300 of devices, how much time you will spend programming all this stuff? Much more natural just to say what you want. Please turn light, or please turn music, or turn off something, or make me coffee. It's much more easier. You don't need no manual, because everybody knows natural language. So it can be used to control the smart home. So it's also a very big market, and also the big domain for application of conversational technology. And actually, was very surprising for me that this boom of smart speakers, and that people are using them to buy something, and even they are satisfied and want to recommend like buying through the smart speakers to others. So what is conversational intelligence right now? Now you can see the same diagram as on the Valentin slides. And he talked mainly about natural language understanding part. But actually, all these parts are today, these modular type of systems, all of these parts are usually a mixture of machine learning models and some rule-based models. And today I will show you how to build with our library such type of this dialogue systems with a trainable, with a RNN model for the dialogue manager. So, okay. But what is the problem if we are doing conversational systems, dialogue systems right now? We have not enough tools to create them from scratch. And usually, when we are in a hurry, we are trying to script all the possible scenarios. And this is like diagram only of a tiny part or for the system for the support in some call center. And as a practice shows, if you have like about 100 rules in your system describing different scenarios, how to talk with the user, your system becomes fragile. You try to add new rules, and you have conflicts with the old rules, and you need to find these conflicts, resolve these conflicts, and this is not easy. So what we can do here, and people are trying to apply machine learning here, and this is what we are doing in our library. And this is what the user experience if you have badly designed chatbot system. You have a lot of rules, but it's still very stupid. How we can do better? So let me talk you about our open source project, which we are doing in our laboratory. So DeepPavlov is for development of production-ready chatbots and complex dialogue systems, but as well for the NLP and dialogue systems research. And our goal is to enable creation of AI-enabled dialogue systems with a set of pre-trained NLP models and predefined dialogue system components, so you can easily assemble your own dialogue systems from these components. And also, given these components and tools to create pipelines from these components to solve your tasks, we also have framework for testing your own dialogue models, because you need not only to create your pipeline, but you need to train it, you need to evaluate its quality. After you did this, you need to integrate it with the adjacent infrastructure, such as messengers or like smart speakers. So we provide integration to the most common platforms for the conversational interfaces. And it's open source distributed under Apache license, so you can freely use it in your products. You can make it a solution which is based on our library. You can make it proprietary, close them, and you can use it as you want. Okay, so where is our library in the stack of conversational technologies today? So if you look at this slide, you can see that on the top you have a lot of platforms which allows you to build simple chatbots, simple dialogue systems with a graphic user interface, such as VTI, Dialogflow, and other systems. And it's on the top of this stack. And at the bottom, you can see machine learning libraries where you have TensorFlow, Keras, and PyTorch. And what we are trying to do, we are trying to fit in between these two layers. Because if you are trying to create your system from scratch on TensorFlow and in Keras, you have to do a lot of stuff in programming your models and creating things which is already tested and debugged for many traditional NLP tasks. But on the other hand, if you are using something like a Dialogflow, on the one hand, you are very limited in terms of the models you can use for your system, and also usually you need to host all your system and use Google services to process your data. And it's not always feasible for you to send your data to Google. Maybe you want to set up your all your processing pipeline on your own servers, so you need some solutions to create the same, to have the same functionality, but on your premises. So we are trying to fit in between these two layers. So we have a lot of pre-built models on top of TensorFlow and Keras, but we have no user interface, and we have possibility to deploy your models onto your own infrastructure. So what are possible use cases for our framework? So let's start from the simplest ones. Sorry. The simplest one is request routing. So you have a user, and user has some request, and you can have different topics for your support system, and for the different topics, you have different human operators. So you need to route user requests to the different human operators. And usually, this can be done either some IVR menu, or you should have one more human here who is switching message, switching the line to the other human operator. So the simplest solution, you just create a classifier which classifies domain of the user request and automatically routes it to the appropriate human operator. So let's go to the a bit more complex scenario when you have a user and you have the same domain classifier, and usually you can have a lot of frequently asked questions where you already have an answer. So in this case, you don't need operator to repeat the same answer again and again. So you can just put these answers in your database, and either to present the most probable replies to your human operator, or as in this case, you can, if your system has a high confidence in the answer, then you can automatically respond to the user request. And if the system has low confidence, then it passes these requests to the human operator to handle on. Another application, if we go to the more complex system, here, in the previous case, we already had predefined questions and answers. But we can do this only for the frequently asked questions. But usually distribution of questions is exponential. So we have a lot of questions which are not covered by our frequently asked questions. But usually in this case, we have some documents, some knowledge base, for example, some description of our products, which can be used to answer the questions. In this case, you can use models which performs search for the substring in your knowledge base, which might be an answer for the request of the user. In this case, systems works similar to the previous case, but instead of ranking possible replies, it just has a few candidates which were found in your knowledge base, and if it has a high confidence, it can provide response to the user directly. But if the confidence is not very high, then it can present candidate responses to the human operator, so improving the quality of the human operator work. Certainly, you can create in our framework simple scripted bots. We are in our framework supporting AI/ML, AI markup language, which you can use to create scripted skills for your dialogue systems, or you can use different components from our library to solve different NLP tasks, such as named entity recognition. So if you have some documents and you want to search through them to tag personal names, organization, geographic locations, numerals, and so on, you can use our library. Or if you want to, for example, search through your document database. Okay, this is what you can do right now with our library. So let me say a few words about our vision and where we are going, what we want to achieve. First, let's take a look at this priority matrix for AI, which were published last year by Gartner. You can see here, I've emphasized here technology which are related to the conversational interfaces, and you can see that they are all put in the highly transformational technologies in terms of benefit. And you see this is a speech recognition, chatbots, virtual assistant, smart speakers, and then conversational interfaces. And you can draw like a roadmap from the speech recognition through virtual assistant and conversational user interfaces to even more ambitious goal like artificial general intelligence. So what we can see here, why I'm talking about like creating more and more intellectual systems which are closer and closer to AGI. So let's look at the picture, what is happening on the smart speaker market. So usually you have these Amazon Alexa, but generally Amazon Alexa is a platform. It's like your smartphone where you can install applications, but here analog of an application is a conversational skill. And now if you read like reviews of the skills in the Alexa, you can find that only 30 to 40% of skills which are usable to users developed by Alexa, but 60 to 70% are skills which are developed by third parties. You can see that at the like a year ago, it was about 40,000 skills in the Amazon Alexa market. Certainly, like 95% of all these skills are like garbage. Nobody will use it, but still there are 5% which are very useful to the users. And it's interesting picture. Why? Because you can see here that if you imagine how more and more general AI agent will be created, usually your picture is that some industrial like lab will create an AI agent, or some academic lab will create AI agent, or some like, I don't know, military lab or something like this will create more and more intelligent systems. But if you look at this picture, it seems that now we have another trend, that more and more intelligent agent emerges and evolves as a product of ecosystem of different companies who are building skills for intellectual virtual assistants. So this is you who are sitting in this audience, you are building these more and more smart assistants because you can develop and you are developing skills which are really useful and which make these assistants more and more smart. And it has a pretty interesting consequences. For example, this makes this technology more robust and less controllable by big corporations because they provide only platform, but you as an independent developers can switch from one platform to another, so the whole product, the whole virtual assistant is not totally controlled by one company. Another interesting thing, that this possible scenario was envisioned maybe in some sense by one of the fathers of artificial intelligence, by Marvin Minsky, in his theory of mind, of intelligence of a human as a society of mind, as a society of cognitive agents. What he said that human intelligence evolved like from animal intelligence during evolution as a society of cognitive agents, and like separate cognitive agents, they are selected to perform some cognitive tasks which are useful for survival of a human, and our intelligence is a society's cooperation of these cognitive agents, which allows us to solve more and more general problems. I found it's nice parallels between what was proposed by Marvin Minsky and what is happening right now. So how many of you knows this picture? Yeah, many of you, yes. So this is like a command prompt from Microsoft disk operating system. And why I'm showing you this? Because we in DeepPavlov are doing another DOS, but not disk operating system, but something like dialog operating system. And we called our framework DeepPavlov because Ivan Petrovich Pavlov, it's one of the most famous Russian scientists who studied how brain works. And we decided to commemorate him in our framework, in our project. And actually 2 days ago, he had a birthday, 170 years. So it's like good time to have presentation about him. So what is happening right now with our framework? So we released our library and published it on GitHub about 1.5 years ago. And you see that we have like a steady growth of popularity. And here is it's a stars on GitHub. And here a number of downloads from Pipey. And you can see that we have more and more downloads starting this from the beginning of this year. And mostly we have downloads from US, from Russia, and from India, about 3,000 downloads every month. So what is the basic idea behind our framework? So as I've said, today, conversational systems, they should have many different skills. So they should be like a Swiss Army knife, which allows you to solve different tasks and different problems. So our idea is that we need to have a framework which allows you to combine different modules, different components which have some functionality, NLP functionality, to combine them easily into the conversational skills. For example, you can here on the left you have a list of some components. Then you can combine them to create one task-oriented skill, for example, restaurant booking skill. Then you can combine another components to have a question answering skill, and combine another components to have a chit-chat skill. But then you need a framework which allows you to integrate this skill and provide smooth conversational experience where you have switching between different skills, and this agent should understand what skill is needed right now. So major abstractions of our framework is an agent. Agent has multiple skills. And inside the agent, besides skills, you have something like a skill manager, which consists of two parts, actually, from skill selector and response selector. And this skill manager decides what skill should be run at the current dialog state. And then every skill is presented as a pipeline of the components. And you have a specific script, which is called chainer, which allows you to build your agent to specify components in your pipeline and their parameters, and train and evaluate your dialogue, your conversational skill here. As I've said, we want to create industrial solution. So to implement our agent, we have this scalable modular architecture, where we have, this is an architecture of the dialogue agent, which handles dialogue sessions and put all the dialogue history in some memory of the agent, which describes the full dialogue state of your system. And then you have a number of different services which allows you to implement your full conversational system. The first one is a pre-processing services, which can read information from your dialogue state and, for example, annotate it, allow you to find, as I've said, for example, names or organization in your data. And then after pre-processing, you have or for example, classify a sentiment of your messages. Then you have a skill selector, which decides what skills should be run at the current dialog turn, and then selected skills has access to the dialog state. They read from the dialog state, and they produce response, and also their own confidence in their response, and write these back to the dialog state. Then all the skills produce their candidate responses. We need like two final steps. We need to decide what response we should surface to the user. So we re-rank all these responses from all the skills based on their confidence and also maybe on the other parameters. Then we use post-processing to surface this response candidate to the user. Below here is a link. You can follow it to see the documentation for this component. So okay, now we have 4 minutes, and I will show you a quick going through the tutorial how to create a very simple restaurant bot, very simple to what was described in the previous presentation, but in our framework. Actually, after that, you can see the link here, and you can go through this like notebook in Colab by yourself. It will take you like maybe half of an hour to create this bot and to train it on the data provided, but you can easily upload your own data and use it on your own data. So what we are doing here, first we start with the data preparation, and we, as I've said, we are creating here a chatbot for the restaurant booking, and we use as a source data set from the Dialog State Tracking Challenge 2, which is data which simulates user conversation with a restaurant booking system in Cambridge. So we import from our framework data reader for this specific data set and read this data. Then you can take a look at this data, and also dataset reader prepares data for the training, so it splits all the data into the training and testing and evaluation data sets. And here is an example of the JSON which represents the data which you have downloaded. It has here its ID of the speaker, it's raw text of the message, which slots were in this message, and what is the action was performed by the system here. This is a response of the system, and speaker 1 is a user. So you can see here, for example, that the user says that it wants some cheap restaurant, and then the system, it identifies slots with the type, price range, and value cheap. So, okay, after we have read our data, we need to prepare them for the training. So we import dataset iterator from the library and put our data inside it, and prepare it for training. And after that, usually you should have like not that much data. So in dataset, it's about 1,000 dialogues, but we will take in this tutorial only 50 dialogues to make it more real life. So you can, even by yourself, you can like, I think that you can spend one day to prepare like 50 dialogues for the restaurant booking system. So we take 50 dialogues, and then we, from the data, we prepare a database, because our system should should execute API calls to the database to retrieve lists of the restaurant in our case. And we prepare this database from the data set, extract information about restaurants from the data set, creating database. Then here is like testing that we created data set in a proper way. And then we are building slot filler. This is the part of the NLU part of your system, natural language understanding part of your system, which takes as an input user input and outputs types and values for all slots which were mentioned in the user requests. Here we will use a very simple slot filler. But first we need to download data like schema which describes your ontology, your slot types and possible slot types and possible slot values. And then we downloaded these slot schema for slot values, and here we are using a simpler slot filling component from our library. And as I've said, we have a specific script which allows you to create a pipeline. And here is we are setting values. We are downloading the script for our restaurant board and setting specific values in this configuration. And then we're building a slot filler. And okay, I have almost no time. And then we are building a dialog manager, which is a recurrent neural network in our case, which should predict the next action of our dialog bot. And this action should be then surfaced. So we have slot values and we have action, and we define in some file templates that given action and given slot values, what should be produced in a natural language, what output should be given by our system. And here is training data, and so we configure the whole pipeline. And here is what is we have at the end. And so we start training, and for the 50 dialogues, it takes about 10-20 minutes to train your RNN, and then you can interact with the system. So that's it. Thank you for your attention. Here is a lot of useful links for